Hello friends, good afternoon. Hello friends, good afternoon. Is it everything clear? Audio, video clear? Please confirm. Audio, video clear? Okay. Yesterday we already I started software engineering subject of computer science. Audio, video clear? Okay. Yesterday we already. Yes, I discussed what is about software engineering. What are the different types of SDLC model? That means software development life cycle. We discussed waterfall model, all types of uh, SDLC model I have discussed in the yesterday session. Waterfall model and incremental and prototype model, agile models, or what is agile, what is the characteristics of agile model, and what are the different types of agile models I already explained in the yesterday sessions, and we solved some previous year's questions also from the software SDLC models. Okay, all type of agile models also we have discussed. It is very important concept. Agile model is a very important nowadays. Okay, please watch. If you did not watch the yesterday lesson, please go to my channel, and in playlists, if you go to the playlists, there is a software engineering playlist. In that you can watch the previous lesson, okay, of software engineering. Today we will see what is cyclomatic complexity. That is very important. Cyclomatic complexity is very important, and we will see what is testing and what is white box testing, what is white box testing and black box testing also we will see today. Please join live. If any of your friends is there, please tell them to join this class. Okay friends, now we will go to the our lesson today. That is cyclomatic complexity. Calculate with flow graph. It is recently in 2019 December, there is a comprehension based question came on cyclomatic complexity for 10 marks. It is very important area. Don't neglect this. Okay, we will discuss now what is cyclomatic complexity. To understand cyclomatic complexity, let's first understand what is software metric. Before the cyclomatic complexity, we will see what is software metric. Measurement is nothing but quantitative indication of size. Measurement, what is measurement? We have to measure something, right? That is a quantitative, means that is in numbers, size, dimension, capacity, etc. Software metric is defined as quantitative measure of an attribute of a software system. Okay, what is software measurement? Software metric means we are measuring something, that is with respect to cost. What is the cost of the project, and what is the quality, size, and what is the schedule. All these will be calculated in the software metric. Okay, first suppose what is measure. Measure means number of errors. What are the number of errors in a program? Metrics means number of errors found per one person. That is called as metrics. Now we will see what is cyclomatic complexity. Cyclomatic complexity is a software metric used to measure the complexity of a program. How the program is, what is the complexity of a program, that we will calculate by using cyclomatic complexity. It is a quantitative measure of independent paths in the source code of a program. Okay, what are the number of independent paths within a program? In the source program, we will find in the cyclomatic complexity. What is independent path? Independent path is defined as a path that has at least one edge which has not been traversed before in any other paths. Suppose if this is a program, suppose if the program started here and this is one path. Suppose if it is a if condition, if it is true, it will go to this path, and if it is false, it will come to this path, right? That is the different types of paths. This is one path and this is one other another path. Like that, independent path means this is a one path, right? If we go in the second path, we can visit another edge. We are not visited yet. Okay, this is a new path, that is called as independent path. That means which has not been traversed before. Before traversal, it was not included. Cyclomatic complexity can be calculated with respect to functions, with respect to modules, methods, or classes within a program. We can calculate cyclomatic complexity within functions. We know, right? Functions means it is a part of code. It will perform some specific task. Module means combination of some functions. Methods or classes. We can draw cyclomatic complexity for functions, module, methods also. This metric was who developed the cyclomatic complexity? Thomas J. M. Cabe in 1976. It is based on a control flow representation of the program. Control flow means how it is the program is executing. That is a control flow. We will draw control flow diagram and we will find the cyclomatic complexity. Control flow depicts a program as a graph which consists of nodes and exists. Graph, what is the graph is having? We already know graph theory, right? Graph is having nodes and edges like this. Cyclomatic complexity also having nodes and edges. You will get idea, okay, in the coming slides, what is a flow graph and what is the need of a flow graph. We will discuss in detail. This is the flow graph, friends. It is a graph. These are the nodes and these are the edges. What the nodes represent? Processing tasks. Why? This is the processing of task. It is processing some task. What is the edge represent? Control flow between these nodes. What is which node is going to another which condition, like that. This is the control flow between the nodes. Edges means this is the flow between the different processing of the task. Flow graph notation for a program. Flow graph notation for a program defines several nodes connected through edges. We will see some different types of flow graph notations like if else, how to represent if else, and how to represent while. Okay, we will see that. This is the sequence diagram. Sequence means it will go like this, one node to another node. Okay, this is while. I will draw here. This is a condition. In while loop, how we will check that condition? If it is true, we will go to the body. If it is, if this condition is true, then only it will execute the body of the program. Otherwise it will terminate and it will go to the end. Okay, after going to the body, again after execution, again it will check condition. For the next iteration it will again check the condition, and again if it is true, then it will come into the body. If it is false, it will go out of the loop. This is while loop, friends. While loop means if it is true, then only it will check the body of the program. Otherwise it will come out of that condition. Okay, it will not execute the body. Next, if else. What is the if else notation? We know, right? This is a if condition. If it is true, it will execute this path, and if it is false, it will go to this path. Finally, they will go to end. Okay, until. Until means how it will do. Initially it will check, it will execute the body once. Either it will not check initially the condition, it will execute the body once. If it is true, then it will continue. Again it will check the condition, again it will execute the body. Otherwise if it is false, now it will go out of the, it will go to the end of the program. This is until. In until, at least once this body will execute. Whereas in while, if it will check the condition initially. If it is false, then it will go out of the program. Okay, it will go out of the loop. Whereas in until, at least once it will execute the body. Then only it will check the condition, and if it is false, it will go out, and if it is true, again it will go to the condition. This is the until. Okay, we will see with examples also. How to calculate cyclomatic complexity? Uh, Mathematical representation. Mathematically, it is set of independent paths through the graph diagram. Cyclomatic complexity means how many set of independent paths are there in a graph diagram. The code complexity of the program can be defined using the formula. To find the cyclomatic complexity, formula is V of G is equal to E minus N plus 2, where E is equal to number of edges and V and N is number of nodes. Otherwise, there is one more formula is V of G is equal to P plus 1. What is P here? P is predicate nodes. Wherever the condition is there, suppose if it is a if condition, if it is while condition, until, if any condition is there, that is called as predicate nodes. How to find the cyclomatic complexity using predicate nodes? We have to, if there is two predicate nodes in that program, we have to add one to that, then we will get the cyclomatic complexity. Okay, that is what is cyclomatic complexity. Please remember this definition also. It is set of independent paths, through the graph diagram. Okay, to find that there are three different formulas are there. Okay, if it is, suppose if I take the one graph, this is a graph. What is the cyclomatic complexity of this graph? Tell me. Number of edges. How many number of edges are there? 1, 2, 3, 4, right? 4 minus number of nodes. How many? 4 plus 2. That is equal to 2. That means the cyclomatic complexity, that set of independent paths through this program is 2. We can easily find, right? This is the one independent path and this is second independent path. and one more formula is number of predicate nodes plus 1. In this graph, actually we take this as a predicate node, means one predicate node plus 1 equal to 2, and total number of region. From regions also we can find the cyclomatic complexity. How many regions are there in this? Tell me. How many node? How many? Tell me. In the this is a graph, right? How many regions are there in this graph? There are two regions. One is inside and outside. Also, we will consider as one region. Okay, that's why two regions. That means cyclomatic complexity we can find in three ways, right? In three ways we are getting two only. That is how we can find the cyclomatic complexity. Suppose here one example program is given. Here I is equal to 0, n is equal to 4. This is while condition. While I is less than n minus 1, j is equal to I plus 1. While j is less than 1, less than n, again in while loop, again if condition is there. Okay, this is the program. We will see how to represent this in a flow graph. Initially, we are not taking all these initialization steps. Okay, just we are starting with the, if we want we can take this also, but no need of extra lengthy flow diagram. Just we will represent predicate nodes. Okay, this is while condition. This first one is while. See these arrows. This is while condition, and if it is true, it will go to the next step, right? What it will do in the while condition? If it is true only, then it will go to the next step. Otherwise, it will go out of the loop. Okay, suppose if it is a true, then after true, again one more while condition came. Okay, this is also one more while condition. If it is true, it is going to the step 3. If it is false, it is going to the last. Okay, after while condition, again which came? This is if condition. What is if? We know, right? If will go two sides. If it is true, it will go to the step 4. If it is false, it will go to the step 5. After if, it is swapping this a of I, a of g. Okay, this is a of I, a of j. It is swapping. Okay, this is swapping. That means it is again there is a edge between 4 to 5. Okay, uh, that means when after that, what is that end do? Again it is, if it, this is while condition, right? In this while, again if it is true, it will go to next second while condition. Here if it is false, it will go to the end do, means again it is going to the first. See here, it is, yeah, here it is doing swap. End do, end do means this is going to the, this is the second while, this is second while loop. It is going to the again first. This is the, yeah, this while loop. If it is true, again it is checking here. Again one more end do. That means the second while loop, it is false means it is coming here, right? If it is false, it is coming here, but it is doing again end do. End do means it will go to the first step again. That is the reason of end do. Okay, I hope you understand this. We will see one more. I will erase everything. Please see once this diagram. Okay, First, this is first while condition. If it is true, it is going to step 2, and if it is false, it is going to step 7. And next while condition is 2. If it is true, it is coming to the condition 3. If it is false, it is going to 6, right? After that, if this is if condition. If condition, after if, it is doing swap. Swap means it is combining these two, and it is swapping the value of ai aj. After that, end do. This is end do means if it is again, it will go and check the condition. Again one more end do. This last one, again it is going to the first of the step, first condition. If it is false, again it will go to the first while initial while loop. Okay, from this diagram we can find the cyclomatic complexity, right? There is, we I already discussed in 3 ways we can find the cyclomatic complexity. We will try to find here itself. Okay, how to find? First one is, first formula is, what is the first formula? E minus n plus 2, right? What are the number of edges here? Number of edges: 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges in this graph. 9 minus, what is the number of nodes? 1, 2, 3, 4, 5, 6, 7. 7 nodes plus 2. 9 minus 7, 2 plus 2, 4. This is a cyclomatic complexity is 4. Now we can find with the predicate nodes. How many number of predicate nodes are there here? How many number of predicate nodes are there? There is a while condition, 1 plus, and one more while condition, 1 plus 1 if condition, plus number of predicate nodes. Again we have to add one more 1. That means 4 is the cyclomatic complexity. Next, what is the next method? Number of regions, total number of regions. What are the total number of regions here? Here we will see we find in 2 ways, right? This is one region, and this is the second region, right? This is the region 2. This is the region 4. Yes. 1, 2, yeah, this is the region 3. After this, one more region is there, that is outer region, right? Yes, this is the other region. These are the total number of 4 regions. If we draw the correct flow graph, then it is very easy to calculate the cyclomatic complexity. Okay. This, see here, just number of edges 9, number of nodes 7, number of plus 2, that is 4. V of G means number of predicate nodes, how many? 3 plus 1, 4. Set of possible execution path of a program. We can see like this also. Number of possible execution paths. How many? Set of independent paths. Cyclomatic complexity means what? Means what? Number of set of independent paths, right? For that set of independent paths only we are trying to find using formula. But from this flow graph also we can find how many number of set of independent paths, right? Paths. One path is 1 7 from starting to first path is 1 comma 7. Second path is 1 2 6 1 2 6 1 2 6 again 1 7. Next third path is 1 2 3 1 2 3 4 5 1 2 3 4 5 2 6 1 again here 2 1 2 3 4 5 2 6 1 7. Next path is 1 2 1 2 3. Yes, 1 2 3 4 5. Sorry, 1 2 3 5 1 2 3 5 1 2 3 5 2 6 1 7. These are the four independent paths in this flow graph. We found this in four different ways, right? This is V of g is equal to E minus n plus 2. V of g is equal to P plus 1. By using the flow graph, we got four independent paths, and number of regions also we got 4. This is the way of finding the cyclomatic complexity. Now we will solve the UGC NET 2019 question. This is a very recent question, friends. This is for 10 marks. They gave this flow graph, and they gave 5 questions based on this flow graph. Now we will try to find the answers for these 5 questions. First question is, how many regions are there in the flow graph F? Very easy, right? Just he is asking how many regions. How many regions? Usually student will do mistake where they will not count outer region, right? Here one region, 2, 3. Yes, 3 is the right answer. They will think like that. But one more region is there. This is the outer region, right? Outer region also we have to consider. That's why total number of regions are 4. That's it. This is the one first region, second region, third region, and this is fourth region. Next one is, how many nodes are there in the longest independent path? We have to see. First of all, we have to see how many paths are there. Then we have to check what is the longest independent path in this graph. Now we will try to write all the possible paths. Okay. First one is, what is first? 1 to 11, right? First one is 1 comma 11. Second one is 1 comma 2 comma 3 6 comma 7, like this. 1 2 comma 3 6 7 9 9 10. After 10, 9 10 1 11. This is the second path, and third one is again this 1 1 2 6 8 1 2 1 2 comma 3. This 2 comma 3 itself become one node. Don't get confused here. This is 2 comma 3 is there, that's why it is also, this is 2 nodes. No, it is one node only. Okay, they gave the node, this node as a 2 comma 3 just. Okay, this is only one node. 2 comma 3 is one node. It will come 1 2 comma 3 6 8 9 10. After 10 1 again, and from 1 it will come to 11. Okay, next path, is there any possibility? Yes, this is there, right? 1 comma 2 comma 3 comma 4 comma 5. This is one node, and yeah, 10. Again from 10 it will go, again it is coming 1, again finally it is coming to 11. Which is the longest independent path here? 1 2 3 4 5 6 7 8. Here these are 8. In here how many? 1 2 3 4 5 6 7 8. Here also 8. Is it right? 1 2 3 2 3 comma 6 7 9 10 1 11. Here 1 2 3 6 8 9 10 1 11. Is there any possibility of more than this length? I think no, there is no other possibility. There are 4 independent paths. We already saw. Cyclomatic complexity also we got how much? How much? We got 4, right? By using the formula and by using the predicate nodes, by using regions also we got 4. It- Definitely we will get only 4 independent paths in the diagram, in the flow graph. Okay, here the question is how many nodes are there in the longest independent paths? We found the 4 independent paths. We found in 2 of the independent paths the number of nodes, which we got 8. Here here one confusion student will get is 2 3. They will take 2 3 as 2 nodes. They will put this 9 answer, but it is not. We have to take as it is one node only. Okay, it is not considered as 2 nodes. That's why the answer is 8. Yes, these are the possible independent paths, and this is the total number of nodes in this possible longest independent path is 8. Next we'll go for the next question. How many predicate nodes are there and what are their names? Predicate nodes means there should be 2 outgoing arrows. That is only predicate, right? Predicate means what? There is a condition. If it is true, it will go to one path, and if it is false, it will go to another path. That is called as predicate nodes. We already saw. Like if, like for, and like while, all these are called predicate nodes. In flow graph, how can we find? There are 2 outgoing edges, right? Here in 2 comma 3 is a predicate node or not? It is a predicate node, right? Because it is having 2 outgoing edges. That means it is a conditional statement. 1 2 comma 3 is the, it should be there in the answer, and next one is 6. 6 is also a predicate node, and next, which is the next predicate node? 2 comma 3 6, 2 comma 3 and 6. Here it is there, and here it is there. Here it is not there. We can eliminate this option. Next, what is the predicate node, friends? 1 is the predicate node, right? Here if it is true, it is coming here. It is false, it is going here. It is also having 2 no outgoing edges. That's why 1. What are the predicate nodes here? 2 comma 3, 2 3, 6 1. Here 10 is not a predicate node, right? There are no 2 outgoing edges. It is not a predicate node, and 11 is also not a predicate node. That's why we can eliminate this third option also. We can eliminate fourth option also. The first option is the right answer. Only 1, 2 comma 3 and 6. These are the predicate nodes. Predicate nodes means there wherever the condition is existing. Okay, that's why option 1 is the right answer, friends. Okay, please remember, if they give bracket as a bracket in one node, we have to consider it as only one node. Don't take it 2 nodes. Okay. Okay, friends, are you getting it? Please tell me. Previously you know this concept or you are studying first time? Please. Okay, we'll see the next question. Same data. What is the cyclomatic complexity of flow graph F? Yeah, this is the repeated question, right? Number of independent paths we already saw. How many we got? 4. That means we can say that the cyclomatic complexity is 4. Please, we will try to find how many number of regions are there here. Here is the first one region. Here is a two region, third region, and outer region is 4. Is the 4 is the right answer. We can find using formula also. What is the formula? E minus n plus 2, right? How many number of edges are there in this flow graph? 1, 2. Okay, I will erase it. How many number of edges? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are total 11 edges. 11 minus how many number of nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. 9 nodes minus 9 plus 2. That means 11 minus 1, 11 minus 9, 2 plus 2, 4. Cyclomatic complexity is 4. This is 4 is the right answer here. Next question is how many nodes are there in the flow graph? Nodes. How many nodes are there? Just they gave just this and they are confusing here, right? This is confusing. Otherwise, we will get the very correct answer. How many nodes are there, friends? 1, 2. We have to consider it as one node. 3, 4, 5, 6, 7, 8, 9. There are how many nodes? 9 nodes are there. Yes, 9 is the right answer here. Okay, there are some properties for the cyclomatic complexity. Following are the properties. V comma G is the maximum number of independent paths. What is the cyclomatic complexity? You have to remember this is a maximum number of independent paths in the graph, right? Then V of G should be greater than equal to 1. At least one path should be there in the flow graph, right? G will have one path if V of G is equal to 1. Minimize complexity to 1. Okay, what is the minimum? We should have minimum only 10 independent paths. More than that is not good. Okay, if the value of cyclomatic complexity is less or equal to 10, considered awesome. That is a very good program or good project. Okay, the code is assumed to be well structured. If it is only minimum 10 independent paths are there in that code, then that code is set, we can call it as good code and it is well structured, and we can testing also, it is very easy to test, right? Okay, now we will go how what is the use of this cyclomatic complexity, why we are studying this. Now you will know what is the yes, how this metric or cyclomatic complexity is useful in software testing. Basis path testing. Here one concept is basis path testing is one of white box technique, and it guarantees to execute at least one statement during testing. If we are doing testing means what we will do, if it is going in this way, suppose it is if condition it is true, means we have to test this, right? We have to uh, write the test cases for this also. in the programming. Is it working fine or not? Like that, we have to write the test cases for true and we have to write the test cases for false. Basis path testing means it will be guarantee at least one statement is there in the during the testing. Okay, at least one statement should be there in that path during the testing. It checks is each linearly independent path through the program. What is the white box testing will do? It will check every independent path in the program, which means number of test cases will be equivalent to the cyclomatic complexity of the program. To do that, how we will decide to write how many number of test cases? That is equal to the cyclomatic complexity, right? If any if five number of independent paths are there, we have to write five test cases. Okay, that is called as a basis path testing. It will guarantee to execute at least one statement during testing. Okay, that is the actual use of cyclomatic complexity. This metric is useful because of properties of cyclomatic complexity are this is m. Suppose cyclomatic complexity is m. Number of test cases to achieve branch coverage is upper bound. Okay, we will see now next what is branch coverage and what is number of m can be number of paths to through the graph. We can test all the only paths and we can test all the branches. There are different types of uh, testing is there. Okay, we will see now what is branch coverage and what is path coverage. We will see. I hope you understand what is the use of cyclomatic complexity now. It is to find the number of white test cases to write in white box testing. White box testing means it will check internal code. If it is how many independent paths are there, how to check, etc. will be checked in the white box testing. Okay, 1 minute I will be coming. Please wait. Okay, friends, now we will see what is branch coverage, what is path testing. We will see now. These are the different. What are the testing approaches? This is a one is functional testing. That means how it is working, and this is outward. We will check everything. There are different. This is called as black box testing. Implementational testing, that is called as white box testing. White box testing is statement coverage, how many statement coverage, how to check, how many test cases are needed to branch coverage, path coverage. These are comes under white box testing. It will check the internal code. But black box testing means functionality. It is focusing on how it is working. There are different types of black box testing also there. That is one is equivalence class testing. You have to remember these names also, very important. Sometimes question is came. they will give some names of the testings, and they will say it is a black box testing, it is white box testing, like that they will ask. Okay. Equivalence class testing, boundary value testing, acceptance testing. In this acceptance testing, alpha testing and beta testing, two are there. And cause effect graphing, pairwise testing, state based testing, these are the different types of black box testing. Now we will see, first we will see white box testing. Okay, in white box testing, what is there? Statement coverage, branch coverage, and path coverage is there. What is statement coverage, branch coverage? Statement coverage is an entity in a programming language which is typically the smallest indivisible unit of execution. The objective of the statement coverage testing is to show that the executable statements within a program have been executed at least once. Statements, these are the executable statements. That statements has to be execute at least once. Throughout all the testings, every statement has to be execute once. At least execute once. That is the coverage of statements. Okay, an executable statement can be described as a line of program source code that will carry out some type of action. What is statement means? Suppose there is a line. If it is a declaration, int a is equal to b, a is equal to 2, and int b is equal to 3, like that, it is also a statement, right? Every statement has to be covered in the testing. That is called as a statement coverage. Executable statement can be described as a line of program source code that will carry out some type of action. Every statement will be do some action, right? That is called as a statement coverage. We will see with example also. A statement coverage is a percentage of executable statements that have been exercised by a test suite. Therefore, to achieve 100% statement coverage, we have to make sure that every statement in the code is executed at least once. 100% statement means every statement has to cover in the testing. So, we will need to test cases executed in such a way that every statement of the code is executed at least once during the test execution. Yeah, statement coverage that does not ensure coverage of all functionality. Now, if we cover all statement, is it cover all the functionality? That will not ensure. We will see now with examples. Okay. After this definition, what is branch coverage? A decision is a program point at which the control flow has two or more alternative routes. I told, right, if it is if else, right? If it is true, it will go this side, and if it is false, like this. This is called as a decision. It has to make some decision at node. A node with two or more links to separate branches. Yeah, this is a branch, right? The objective of decision coverage testing is to show all the decisions within a component have been executed at least once. In our testing, every decision has to be covered, right? If it what is happening, if it is true, what is happening, if it is false, like that, it has to cover every decision also. A decision can be described as a line of source code that asks a question. 100% decision coverage implies both 100% branch coverage and 100% statement coverage. If we are covering every decision, that means every branch will cover and every statement also will cover, right? That is the important statement. Every branch taken each way, true or false. It helps in validating all the branches in the code, making sure that no branch leads to abnormal behavior of application. If we test every branch, if they are all are working fine, then it is, what is the meaning of that? There is no abnormal behavior of that application. That we have to ensure that we are checking, we are writing the We are writing testing for each decision also. Okay. Is branch coverage the same as decision coverage? The branch coverage is closely related to decision coverage, and 100% coverage they will give mostly same results. Okay. Decision coverage means the coverage of conditional branches. Branch coverage measures the coverage of both conditional and unconditional branches. Okay. That is the difference between decision and branch. Decision means only it is a conditional branches. Branch means both conditional and unconditional branches. Okay. That's why we have to see every branch. What is path coverage? Path means in this the test case is executed in such a way that every path is executed at least once. Suppose it is a program, it is if it is false, it is going like this. If it is true, it is coming here, and again here if condition, it is coming here. It is while it is coming here. Previous program, right? Like this. Path means every path has to execute at least once. Path 100% path coverage means all the paths in this flow graph has to be executed at least once. This is one path, and this is path number 3. This is path number 4. Like this, all the paths has to be executed at least once. That is a path coverage. All possible control paths taken, including all loops. Path taken 0. Uh, every statement in the program is guaranteed to be executed, right? In path coverage, we are covering all the paths. Okay, that means every statement will be covered in the 100. If it is 100 percentage path coverage, if we do all the coverage of all the paths, then state all the statement also will cover in this 100 percentage path coverage, right? Yes. Flow graph, cyclomatic complexity, and graph metrics are used to arrive at basis path. Okay. How to calculate the statement coverage, branch coverage, and path coverage, friends? For that also we have to draw a flow graph, right? From the flow graph only we will came to know that how many which path is executing all the statement coverage, and which is how many number of test cases are needed to cover all the branches, how many test cases are needed to cover all the paths. By using the flow graph only we can find. Here we have to remember nodes represent entries, exits, decision, and each statement of a code. Edges represent non-branching and branching links between nodes. Okay. Here there is a one example. See here how to write the again how to represent in a flow graph. Initially, we are reading P, Q values. We are reading P, Q values, and here one condition, if P plus Q is greater than 100, then print large. Here P plus Q is greater than 100. Yes, then it is coming to, we have to maintain like this. First, this is 1, this is 2. Again, whichever are there in the nodes, we have to represent it 1. Nodes are represented 1, 2, 3, and here what here edges are represented A, B, C, like that. To clear our idea, okay, it is 1, 2, 3, 4, 2, 3, 4, 5 here. Here A, B, C, D, and E, F, G, H. Okay. Now see, this is a if condition, right? If it is S, P plus Q is greater than 100, it is going here and it is printing large. Again here end if means they both come here. If it is no also, it is coming here. After that, if again one more condition here, if p greater than 50, it is again print p is large. It is printing the statement p is large. Else it is going this side. Okay, it is, if it is if p is not greater than 50, it will go this side. If it is p greater than 50, it is printing large. Okay, now we will see how to write the test cases to path coverage, branch coverage and statement coverage. Okay, see here, coverage can be calculated for all the three techniques mentioned above. First, statement coverage. Okay, statement means these are the statements, right? Whatever are there in the brackets, these are the statements. Okay, these are the different statements in the program. Okay, we write all the statements. This is read p, read q, this is one statement. And if p plus q greater than 100, this is second statement. Print large, this is third statement. And if next p greater than 50 is another statement. Print large is another statement. These are the different statements in the flow graph. Okay, to here one is given 1a, that means it is coming like this: 1a, 2b, e, 4f. Please tell me how much percentage of statement is covered in this. Here it is started here, and a, 2b, e, 4. Okay, here how many total? Here I am covering 1a, 2b, e, 4f. Okay, I am covering this much statements. Then how much percentage of statements are covered? Tell me. Here actually total how many statements? 1, 2, 3, 4, 5 statements are there. Out of 5 statements we covered in this path, we covered 3 statements. That means 3 by 5 into 100, right? That means how much percentage? 60 percentage of statements are covered in this path. That is how we can find the percentage of coverage. Yeah, here 1a, 2b, e, 4f. In this path we covered only 3 statements out of 5 statements. That means 3 out of 500 means how much percentage? 60 percentage of statement coverage. 2 statements are not covered in this testing. Okay, next, branch coverage. We will see branch coverage. Actually, how many branches are there is in this program? First tell me. Here if it is true, it is going like this, it is coming like this, and here again it will come here, and if it is true, it will go this. This is one branch, right? This is one branch. And suppose if it is here, it is false, that means this is another branch. Okay, if this only, if it is true, and it will come here and it will come here. And if here p is less than if here p is greater than 50, it will go this side, but here p less than 50, it will go this side. This means here 2 branches. From this side we are getting 2 branches. Again same like that only. If it is no, it will come here. If p is greater than 50, it will come this side, and if p is less than 50, it will come this side. That means how many? Here also 2 branches. Total how many branches? 4 branches are there. We can see with example also. Eraser is not working. I'm seeing like that. Okay, sorry. Yes, here we are doing branch coverage, right? Yes, I am erasing here everything. Okay, friends. Now, what is here? P plus Q is greater than 100. P plus Q is greater than 100. Suppose I take P is equal to 40 and Q is equal to 60. That means what it will do? What is if P plus Q is greater than 100 or not? No, it is not greater than 100. That's why what I will do? I will change it. I will take here Q is equal to how much? I will take Q is equal to 70. Okay. What it will do? P plus Q is greater than 100. Then it will go this side. After coming here, is P greater than 50? No. P is not greater than 50. It will come this side. Okay. This is one test case. This is one test case. Here, if P plus Q is greater than 100, if I take here 40, P is equal to 40, Q is equal to 40, P plus Q is greater than 100? No. 40, Q is equal to 60. If it is P is equal to 40 and P is equal to Q is equal to 40, it will P plus Q is less than 100. That's why it will come here this side, and here P is greater than 50. No, P is less than 50. That's why P is less than 50. That's why it will come this side again. These are that's why we have to write the test cases. Okay. Uh, next, next what? If I take P is equal to 50 and Q is equal to 40, what it will do? Again, P plus Q is not suppose I will take 55 here 55. I will take 55 and here 40. What it will do? 55 plus 40 95. It is less than 100. Here it will go here, and if now 50 P is greater than 50, right? That's why it will go this side. Next here uh, again what I will do? P is 60 I will take, and Q, sorry, P I will take 40 and Q I will take 70. No, P I have to take yes, I will take 60 and Q I will take 40. That means no, P I will take 50. 60 plus 50 how much? 110. Here P is this is greater than 100 and it will come this side. After coming here, P is also greater than 50. That's why it will come this side. Total how many paths are there? How many branches are there? 4 branches. But here what he covered? What? 1A, 2B, E, 4F. 1A, 2B, E, 4F. How many branches are covering? This is the path. 1A, 2B, E4F. Only this, right? Only this branch. Remaining 3 branches it is not covering. That means how much it is covering? How many branches it is covering? Only, yes, 2 branches it is covering, right? It is covering this branch and it is covering this branch also. 2 branches. Here is no and here also no. That means it is covering 2 branches out of 4. That means 2 by 4 into 100. 50% of the branch it is covering. right? Next one is path coverage. Path coverage means just paths. How many paths are there? Here also 4 paths. How many paths are existed in this 4 paths? This is one path, and this is another path. This is the this path, and this is another path. There are total how many paths are there? Here 4 paths. Here it given 1A, 2B, E4F. 1A, 2B, E4F. That means only this side. That means how many paths it is covered? It is covered only one path, right? Out of 4 paths, it covered only one path. That's why 1 by 4 into 100. That means only 25% of the path it is covered. Is it clear? Please tell me, is it clear? Is it clear or not? Yes, here 1A, 2B. Branch coverage is clear. Just here 2 branches are there. Here in the first one 2 branches, and here we are not just checking condition, friends. So please try to understand here. I think here I should not tell this values. It is not applicable here. Just branches we have to take here. Only branches here. In branch coverage, we have to just see the branches. Here how many branches are there? 1, 2. Here 2 branches. 1, 2. Here how many branches are there again here? Here 1, 2. Total how many branches are there in this? One branch, second branch, third branch, fourth branch. That's it. Okay, out of 4 branches, it is covered 2 branches. This is one branch and this is a second branch. Okay, out of 4 branches, it covered 2 branches. That means 2 by 4 into 100. Okay, friends. Here there is no need of checking values here, because just we are doing branches. Only the sides. We are not checking is like this. Path means every path we are checking. Path coverage is, oh, we are doing every path. If it is one path and it is the second path, and if it is false, it is the one path, and if it is false and p is greater than 0, it is other path. Like this path is checking like this. But branches, just we are doing, how many branches are there total? Total 4 branches are there. This given, this given is checking how many branches? Please try to understand. Previously I have taken values, but that is not correct in branches. Here in how many branches? Here first branch and second branch. Again here one more, third branch, fourth branch. Here given is 1A, 1A, 2B, 2B means this side, and E, 4F, that means this side. Here how many branches it covered, friends? It covered 1, 2. 2 branches it covered. Actually total branches were 4. 2 by 4 into 100. That's why 50% branch coverage is covered here. Okay. But here in the path, how many paths are there total? Total paths are 4. But we covered only one path, right? In 1A, 2B, E4F. 1A, 2B, E4F. 1A, 2B same, right? Same. In the branch coverage also same given, and in the path coverage also same given, but it is saying 25 percentage of path coverage, but whereas in the branch it is saying 50 percentage of branch coverage. Did you observe this difference? Here just we are checking only branches. Total 4 branches are there, it is covered 2 branches. Okay, these 2 branches, that means 2 by 4. But here in the path coverage we are checking roots, every root. Okay, in this given 1a 2b 1a 2b 4f, how many paths are covered? Actually 4 paths are there here, right? 4 paths I already given with examples also. Actually I have given here in a branch coverage, that is not right. Please rectify friends, sorry for that. Okay, actually we have to give values here in the path coverage, we have to give and how many paths are existed. Okay, here we have to check that. Here only one path is covering by using 1a 2b e4f, right? Actually total how many paths are there? 4 paths. 1 by 4 into 100. That means how much percentage of path is covering in this given path? Only 25 percentage of paths are covering in the given path. Okay, I hope you understand this. This is one of the previous year's question. Okay, please. For this also we have to draw the flow graph. Here the question is asking number of exhaustive tests. Here the given is boolean A, boolean B, boolean C, boolean D. There are the 4 variables given in the function MCQ. Okay, number of exhaustive test means we have to do, actually 4 is given, that means 2 power 4. 16 exhaustive tests we can do with the 4 given variables, but 16 is okay, answer 16 is right. Okay, from here B, C we can eliminate. Now next one is question is asking about number of tests to achieve full statement coverage. Number of tests to achieve full branch coverage. For this what we have to do? We have to draw flow graph, and from that flow graph we have to see how many number of ways are there to cover complete statement coverage. How many number of different independent paths are there to cover full branch coverage, that we have to find now. Please try with yourself. Please try. Yes, here again we have to draw the flow graph here. Okay, I will show you. Please after this also you try with yourself. If you don't get, then only you will try with it. Actually what is the first statement? Int answer is equal to 1. I am taking it as a, answer is equal to 1. Next one is if a, answer is equal to 2. If a, this is a condition, if it is true, answer is equal to true. Okay, if it is else, if that means if it is false, it will go to the again another condition. Else if it is true, again if it is true, answer is equal to 3. It is false, again it will go to one more else if C. If it is true, again one more if condition inside the else if. Okay, if it is true, then and this is the one more if condition. If D, answer is equal to 4. Okay, false in else if it is D, here 2 are there, right? 2 if means if it is true, it is answer 4, and if it is false, written answer. Yes, one is there written answer for all which after the we have to return answer, right? If it is true, answer is equal to 2, return answer. We have to go to return answer. In else if also, if it is true, answer is equal to 3, we have to return answer. Okay, again, else if C also, in the, if it is true, in this true, if D, answer is equal to 4, you have to return answer. Else if false also, you have to go to the return answer. Okay, next, finally, else if. In else if it is true, it is going to the if condition. If it is false, it is going, and finally it is going to return answer. Please try to observe this code once. Yes, int answer is equal to 1. First, this is A. If A, if A is true, answer is 2. Then return answer. Return answer is for everything. Okay, this is after this closing bracket. That means everyone is go, at last it will go to this return answer step. Okay, answer is equal to, it will go to return answer. If it is false, if A is false, it will come to else if B. After coming to else if B, if it is true, it will return answer 3. It will go here. In else if B it is false, it will come to else if C. Okay, inside else if C, one more if condition is there. That means if else if C is true, it will go to this if condition. If this condition, if condition is true, it will return answer 4. It will go to return answer. If in this if also, if it is false, here it will not mention, but we have to understand. If means there is two conditions, right? If it is true, if it is false, we have to imagine that. Okay, if false means again it also returns answer. After, in this is the true condition for else if, right? If it is in else if C, in else if C, this is a true condition, but if in else if it is false, it is also go to the return answer. Okay, this is the complete flow graph of the given code. This is a complete flow graph of the given code. Now what we have to do, we have to check what is the question. Minimum number of tests to achieve full statement coverage for MCQ. Okay, full statement coverage means what is statements? Whichever are there in this brackets, these are called what? Statements, right? First of all, we have to write minimum number of tests to achieve full statement coverage. To cover full statements, how many test cases we need, friends? Okay, friends, statements means first we have to cover this, right? We have to cover this area to cover this statement. This one, this is one test case. Next, in this path to cover these statements, after coming here, we have to go here to statement to next in this path to cover this statement and this statement, we have to go like this statement. We no need to go this side, right? There is no statement here. Now here also there is no need to go this in this path also, because there is no statement. That means total how many test cases are needed to come to cover complete statement coverage? Three test cases, right? Three test cases are needed to cover complete statements. Next question, what is the next question? M3. M1 we did, M2 what we got in M2? 3. From here itself we got our answer, but we will try because here it is 4. That's why the answer should be A only. Minimum number of tests to achieve full branch coverage. Next, what we have to do? We have to do full branch coverage, right? Full branch coverage, I will change the color. Okay. Full branch coverage means what we have to do? How many branches are there here? Here, 1, 3. Here, one more branch, 4, 5, 6. Is it okay? Yes, branch coverage. Will erase it. It is very clear then. Okay, here we have to see branch coverage, right? Full branch coverage. That means this is one branch, one test case, and next we have to come here, right? This is we cover here one branch, and we came here. From here, how many test cases? This is the second branch, and from here, next, this is the third branch. From here also, we have to go like this. This is the third branch, and this is the fourth branch. This is the fifth, right? Only five test cases are needed to cover all the branches. From here we are covering this branch. Next, from here we are covering this branch. From here we are covering this branch, and here we are covering false this branch, and finally from this we are covering this branch. All the branches are covered with 5 test cases. Okay, now these are the branches also I wrote here: A1, B2, CD, A1, B2, CD, and like this. I wrote the names of that branches. How many are there? 5. Minimum number of test cases are needed to cover full branch coverage. How many to statement coverage? 3. Minimum number of test cases are needed to cover full statement coverage. Yes. Yes, this is the answer of this question. Okay friends, please take some break. After some time again I will take live. If it is possible, please join live. Okay. Please take some break. I will finish today testing next module software design. Okay. This is all about testing part. Then the remaining part is black box testing. Just we have covered in this session cyclomatic complexity, how to find cyclomatic complexity, and I have covered white box testing, right? In white box testing, what are there? Statement coverage, branch or decision coverage, path coverage. Okay, how to calculate the percentage of branch coverage, statement coverage. Okay, everything I have discussed. Please watch this, and please share with your friends if any of your friend is preparing for the UGC net. Okay, thank you friends. Thank you for watching. Uh, Today I will discuss again the software design and black box testing, different types of black box testing techniques Today we will complete the testing part. Thank you friends. Thank you very much. Good evening. Bye.